Okay, today we're going to do the lab comparing the density of different metals. Um, we can use density, if you recall, to identify if an object is lighter or heavier than water. Each metal has its own specific density based on how compact it is, how much mass is in that given space. Okay, so different materials can be distinguished from one another because they have different properties. One property that is often used to identify unknown materials is its density. Density is defined as the ratio of a material's mass to its volume. So how much matter is in that space? By measuring the mass and volume of a sample of material, you can obtain an important clue about the identity of the material. So with this lab, what we want to do is be able to measure the mass and volume of 4 metal samples. We want to calculate the density of each sample. We want to compare the calculated densities with known densities of specific metals, and then we want to identify each metal sample. This time around, we have some pre-lab questions, some things we need to know before we start the lab. So the first thing we have to do is identify the formula to calculate density. And if you recall, that is D equals M divided by V, so mass divided by volume. The units for density, remember, are grams per milliliter if your volume is measured with the graduated cylinder, like we're doing today, or grams per centimeter cubed if we had to do 3 measurements using a ruler. So if a sample of metal X has a mass of 85.6 grams and a volume of 12.1, what is the density? So remember, we have to write out our formula, D equals M over V, and then we're going to put in our numbers. So D equals 85.6 grams divided by 12.1 milliliter. We have different units, so we have to keep those units. So I'm going to use my calculator here. 85.6 divided by 12.1, and I get 7.07. Now we have to look at sig figs. It's actually 7.0743. The next number is 4, so my 7 is all I need to do because that's the least number of spaces. I'll write my units, grams per milliliter. Little m, big L, because milli is a portion of a liter. Capital M, capital L, megaliters means it's bigger than a liter. So if a metal bar has a density of 19.3 grams per milliliter and a mass of 50 kilograms, what is the volume? Now we have a few things we need to do. First, we need to change our kilograms to grams. So if I take 50.0 kilograms, and we're going to do our sig figs here, I know that there are 1,000 grams in 1 kilogram. So I'm going to take 50 times 1,000. Let's do the math. 50.0 times 1, 1, 2, 3, and we get 50,000 grams. Then I have density and I have mass. That means I'm looking for volume. So V equals M divided by D. So V is going to equal 50,000 divided by 19.3. So my mass divided by my grams divided by grams per milliliter, those grams will cancel out, leaving my units in milliliters. So if I take 50,000, divide that by 19.3, I get 2590.67. Okay, so we had 3 sig figs, so we're going to go 2.59 times 10 to the, we needed to move that 1, 2 to the third. I had to move my 0. Okay, my volume, milliliters. All right, so you guys can do that. Now on the computer, it's going to be easier to do all of that because you can just type where you need to do it. All right, following our procedure says to weigh metal 1 on the balance, and then we're going to record it on our table. I have my 4 graduated cylinders already pre-filled just to make this video work easier. Who wants to watch me make a mess all over the table? So I have 1 for each of my metals. Then I'm going to dry everything, and we'll figure out all of our work. So let me flip this over. Okay, on my data table, put my metals here to help hold my paper down. So mass 1, I'm going to do this nice shiny one. I can't, you know. The mass is 49.50. Put that one there. I'm going to do this coppery color one. I'm going to guess it's copper. 57.90. Put my little G's. I'm forgetting that step. Ooh, we got another shiny one. Ooh, that one's light. Wow, that one's 18.10 grams. Ooh, that one's really light. And then we have this yellow one. And that is 53.40 grams. Okay, so I got my mass for each one. I can turn that off. Move it out of the way. Okay, so now it says we need to get the volume of each. So I'm going to take my graduated cylinder here. The volume of it, I need to get down and look, is about 79.5. So 79.5 milliliters. I'm going to gently drop this in so we don't splash. And it moved up to 85.5. So 85.5 milliliters. Now I need to take 85.5 minus 79.5, and I get my sample is 6 milliliters. Okay? Let me do the others, and then we can get through everything. So the second one is at, I'm going to say 78.5. I was really trying to get to 80, but I didn't quite get there. Gently drop it in, and it went up to, I'm going to say 84.0. 84.0 milliliters. So 84.0 minus 78.5, and I get 5.5 milliliters. Okay, the next one, I'm going to say 82. So 82.0 milliliters. And it went up to 88.0. So 88 minus 82 is going to be 6 milliliters. And then the last one we need to do, we are at 79.0. That's my starting point. And it went up to 85, 84.5, I'm going to go. 84.5 milliliters. So 84.5 minus 79 equals 5.5 milliliters. Okay, so now for each of these we need to figure out the density. Remember, it's the mass divided by the volume. So 49.50 divided by 6. We're going to get 8.25. 57.90 divided by 5.5. And we're going to get 10.5. 18.10 divided by 6. And we're going to get 3.02. I'm going to round that up to 3.02. 53.40 divided by, oops, clear that one out. 53.4 divided by 5.5. I almost did the whole volume, sorry. 9.71. All right. Then I have to do my units, grams per milliliters for all 4 of these. I'll write my units in the same box. Okay, now I'm going to have to look that up and figure out what each metal is, okay? You can go to Google and type in the density and see what metal it comes up with. Maybe if you need to, put next to this shiny copper color light shine, because it was a lightweight. It's got to be some light metal. And then this was a yellow color. Okay, so that'll help you figure out what it is. Okay, then we need to look up the densities for the following metals. Write those for your analysis question 1. And then based on the actual density of metals from question 1, list the metals for unknowns 1, 2, 3, and 4. So write what each one is. Write what the actual density of each one is. And you know what? I'm just going to say refer to table. You guys do not need to do question 2. Refer to table. Type that up there so I know. Check your answer with the teacher. Compare the density you calculated. Well, gee, you guys don't have to check your answers with me because I'm working with you. But let's, what could be 2 possible errors in the lab? Let's think about this. First one, we could have had an error reading our volume, correct? So we could have had error reading volume in either the initial volume or when we put the metal in. So error reading volume at any point, because then we don't have to write it all the time. And then we also could have had an error reading the balance. What if our balance only went to whole numbers? Then it wouldn't be very accurate. So not a very precise balance. It only went a couple spots, okay? All right, so what you guys will need to do is answer questions 1 and 2 for the real world. Modern jet airplanes are built primarily out of aluminum and another metal, titanium, which has a density of 4.5 grams per milliliter. Why do you think these metals are preferred over other metals such as iron and lead? My recommendation is look up what the densities are for iron and lead and think about why we would want to use lighter metals, and then give me a reason, okay? All I need is one reason. Number 2, many metallic materials are alloys or a mixture of 2 or more metals. For example, brass is an alloy of copper and zinc. How would you expect the density of brass to compare to the density of pure copper? So do you think the density of an alloy is going to be greater than, equal to, or less than the pure material? Tell me what you think, greater than, equal to, or less than, and why. That's what I need for those 2. All right. When you are done with those 2, as well as figuring out your metals on the data table, turn this in via the submit button on Schoology, and I will get it graded for you. Have a great day. Bye.